So today you are going to learn about sequences, okay? So when you hear the word sequence, as in a sequence of events, you likely think of something happening first, then second, and so on. In math, the word sequence also deals with outcomes that are first, second, third, and so on. Moreover, a sequence is a function whose domain is the set of positive integers, okay? Of positive integers, okay? A sequence, as I see it, is kind of like a collection of numbers, okay? So the first example, it tells you to write down the first 6 terms of the following sequence, okay? You don't need to graph it. We don't need to graph it. You just need to tell me the first 6 terms. So the first term is going to be, we are going to call it a sub 1. Why a sub 1? Because it's the first term. So what you're going to do is you're going to plug the 1 here and here. Okay, so what would you have here? You have 1 squared, which is 1, and then you would have 2 times 1, which is 2, plus 1, which is 3. So your first term of the sequence is going to be 1/3. The second term is going to be a2, which is going to be equal to 2 squared divided by 2 times 2 plus 1. Okay, we know that this is going to be 4 divided by 5. Okay, so this is the second term. The third term that you have here is going to be 3 squared divided by 2 times 3 plus 1. And this is going to be equal to 9 divided by 7. Okay, now the fourth term, you know that it's going to be 4 to the power of 2 divided by 2 times 4 plus 1. Okay, and you have that is going to be 16 over 9. The same way, you have a sub 5 is going to be equal to 5 power of 2 divided by 2 times 5 plus 1, and this is going to be equal to 25 divided by 11. And finally, the sixth term is going to be equal to a sub 6, which is going to be equal to 6 squared times 2 times 6 plus 1, and this is going to be equal to 36 divided by 13. Okay, so to answer to this question, write the first 6 terms of the following sequence. You know that the 6 terms are going to be 1/3, 4 over 5, 9 over 7, 16 over 9, and last 25 divided by 11, and last but not least 36 divided by 13. And those are going to be your first 6 terms. Okay, so for example number 2, it tells you write the first, again, 6 terms of the following sequence, and you're going to be like, okay, so what's up with this? Well, you're going to do kind of like the same, even though the notation here, it looks kind of weird. You do b sub 1 is going to be equal to negative 1 to the power of 1 times 2 times 1. Okay, so you know that negative 1 to the power of 1 is negative 1 times 2 is going to be negative 2. Okay, in the same way, you have that b2 comma b2 is going to be equal to negative 1 squared times 2 times 2. Okay, so you know that this is going to be negative 1 to the power of 2 is positive, so it's 1. 2 times 2 is 4, so this is going to be 4. b3 is going to be equal to negative 1 to the power of 3, that you know that it's going to be negative, times 2 times 3, which is 9, so this is going to be negative 6. Okay, I don't know where I was thinking about the 9. Okay, so b4 is going to be equal to negative 1 to the power of 4 times 2 times 4, which you know that this is going to be positive, and this is going to be 8, so this is 8. b5 is going to be equal to negative 1 to the power of 5, which you know that it's negative 1. 2 times 5, okay, so this is going to be equal to negative 10. And last but not least, b6 is going to be equal to negative 1 to the power of 6. 2 times 6, okay, and this is going to be equal to 12. Okay, so the first 6 terms are going to be negative 2, 4, negative 6, 8, negative 10, 12. Okay, so these are the 6 terms. We call this an alternating series because it's alternating sign. In calculus, you'll learn more about this alternating sequences, okay? Example number 3, you need to write the first several terms of the sequence, okay? In this situation, we need to write 6. Okay, this one is what we call kind of like a piecewise function, if you remember the piecewise functions back in the day, okay? So the one that we want is, forget about this one. This one is the same example that we have over here, so the one that I'm looking at is this one, okay? So C1 is going to be equal to what? Is 1 even or odd? Well, you know that it's odd, therefore this is going to be 1, okay? What happens with C2? C2 is equal to, you know that 2 is even, so 2 squared is 4. C3 is going to be equal to, you know that it's odd, so it's going to be 3. C4 is going to be what? Even, so 4 times 4 is 16. C5 is going to be equal to 5 because it's odd, and C6 is going to be equal to 36. Okay, so if you want to write the first 6 terms, you know that these are going to be 1, 4, 3, 16, 5, 36, ... I would always write it in the order that you got them so we can see the pattern. Otherwise, finding the pattern would be quite difficult, okay? So I would always use the pattern that they are giving you, okay, with the formulas. Okay, for example, number 4, what you have here is you need to find the formula for each of the sequences. Basically, this is the backwards process. Okay, so what are you thinking? Well, I know that when I plug 1, I'm going to have a 1/2. When I plug the second term, which is 2, I'm going to have 1/4. 3, I have 1/8, and 4, I have 1/16. Okay, this is the term, right? The number of the term. So for the first term, I have 1/2. So what's this pattern? Okay, so I know that I'm talking about a sequence, so I'm going to start with this notation, okay? Now, what's the formula for my sequence? I realize, okay, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16. Therefore, from that, I can create my formula, and this is the formula for the sequence, okay? So you need to see the pattern here. Okay, now let's look at B, okay? So for B, it's a little bit interesting because you are like, okay, so this is 5, this is 7, this is 9, this is 11. Okay, so I know that this is my first term, second term, third term, and fourth term. What's the situation here? What's the pattern that you can see? I can see that I'm adding 2, okay, 5 plus 2, 7 plus 2, 9 plus 2, 11. Okay, so you realize, okay, so these are my terms. So how in the world I can create a formula? Okay, I'm going to call this one Bn. Okay, so for this one, what I'm going to do is, okay, I know that, well, it's going to be the original, okay, but the original starts with 5. Okay, so what I did is and we're going to see this when we see arithmetic sequences, this is going to be the formula. Why it's going to be the formula? Okay, so because if I plug 1 here, okay, so you have 2 plus 3 is 5. Then if you plug 2 here, you have 4 plus 3 is 7. If you plug 3 here, you have 3 times 2 is going to be 6 plus 3 is 9, and so forth. Okay, so this is going to be your formula. Okay, remember, you need to find the pattern. Okay, similarly here, you have that this is your first term, second term, third term, and fourth term. You're going to be like, oh my goodness, how in the world we can change, you know, from positive to negative and so forth? Well, this one that you have over here, it's giving you a hint. Okay, I'm going to call this sequence C of n. Okay, so if you have C of n, the formula that you have here is going to be -1 to the power. Since I'm starting with the negative, I'm going to write it like this. Okay, so if I plug the 1, I have that it's negative. If I plug the 2, I have that it's positive, and so forth. Okay, so this is what we call the alternating sequence. Okay,